Myself, Channel Popat. We will discuss soil water today. Soil water. The water present in the voids of soil mass is called soil water. In this figure, you can see voids between the soil particles and the white portion. This white portion is showing soil water. Furthermore, soil water has two basic types, which are free water and held water. Held water is having furthermore three types: structural water, adsorbed water, and capillary water. Let us understand them one by one. Free water. Free water is the water in excess of the moisture that can be retained by the soil. So, soil has basic some moisture, but whenever in excess of that moisture there is some water is free water. Free water moves in the pores of soil under the influence of gravity, and that is why it is known as gravitational water. Held water. Held water is that water which is held in the pores of soil mass because of certain forces of attraction. So, due to some forces of attraction, the water is held in the pores of soil mass. It is not free to move under the influence of gravity. So, like previously understood, free water, it is not free to move under the effect of gravity. Structural water. The water chemically combined in the crystal structure of the mineral of the soil is called structural water. In this figure, you can see a crystalline structure of the mineral. Whenever your water is held in this structure, it is structural water. This water cannot be removed without breaking structure of the mineral. So, to get the water out, we have to break the water. We have to give it 300 degrees Celsius temperature to remove the water. Adsorbed water. Water held by electrochemical forces existing on the soil surface is called adsorbed water. Here, electrochemical forces are mentioned, and as we remember, electrochemical forces do include electron, proton, and neutron. Let us understand basic soil particle. Generally, soil particle is generated like this. Negatively charged soil particles are in the center and positively charged ions are in periphery or circumference. So, the water which is held in between the periphery layer or in between exchangeable ions is known as adsorbed water. Let us understand adsorbed water more. The electrically attracted water that surrounds the clay particle, we are talking about clay particle only, is known as diffused double layer of water. When clay particle is there and there are electrically attracted water particles are there, it is known as diffused double layer of water. The adsorbed water is also called as hygroscopic water. Let us understand properties of adsorbed water. It is having more viscosity. Now what viscosity is? Viscosity is resistance to flow. Whenever a fluid is trying to flow and it is resisted by something, that resistive force or resistive property is known as viscosity. It is having more surface tension. What is surface tension? Whenever a fluid is trying to flow from some surface, the forces of attraction attract the molecules and they create a force, that is surface tension. Heavier than normal water. So adsorbed water is in weight, it is heavier than normal water. Boiling point is higher than normal water and freezing point is lower than normal water. So these were the properties of adsorbed water. Capillary water. The water held in the interstices of soils due to capillary forces are called capillary water. Now, in this figure, you can see these are soil particles, and these are interstices between the soil particles, and in interstices there lies some water. There is some water held. That water is known as capillary water. In this figure we can see soil particles is here. It is circumferenced by some water, that is structural water. It is in crystal structure of soil particle. Then in the periphery you can see a line having water particles, that is adsorbed water, and the red arrow in the interstices there lies capillary water. And in this you can see a hole here. If there is some water here, that is free water or gravitational water that can move by gravity, and hell water cannot be moved by gravity. Let us move further. The capillary water is always under tension. It is always under negative pressure. Properties of capillary water are as same as normal water. Importance of capillary water. The capillary water can be easily extracted by the plant roots for their growth. Hence, capillary water is useful for the crops. So, we do understand crops do take water from the soil. That water is generally capillary water. So, it is very much useful. Capillary water is very much useful for growth of the plants. The capillary water has a considerable effect on stress conditions in the soil mass. Let us understand now stresses: total stress, effective stress, and neutral stress. So basically, what is stress? At any place in a soil mass, the total stress is the total load per unit area. So basically, stress is total load per unit area. On some unit area the load is coming, then it is stress, which is load per unit area. It is in generally kilonewton per meter square or newton per meter square. Total stress may be due to two reasons: sulfate of the soil or overburden on the soil. Let us understand total stress in depth. Let us assume a portion of the soil. Here we can see dry soil in the upper portion and saturated soil in the bottom portion. Now dry soil is up to height h1. Now we need to understand that this inverted triangle is showing water table. So we can see dry soil up to height h1 and saturated soil up to height h2. Now if we define a point O here, and if we can construct a pipe here, then the level of water will be up to h2 height due to the water table here. Now let us calculate total stress for this. Now total stress sigma at point O. Total stress is denoted by sigma. Now at point O, let us find out total stress. For total stress, we need to calculate unit weight into height of the soil. So unit weight of the first soil, that is dry soil, that is gamma D, dry unit weight, into height h1 plus saturated unit weight into height h2 for this soil. Effective stress, which is denoted by sigma dash. It is the pressure transmitted from particle through their point of contact through the soil mass above the plane. So it is nothing but effective stress is what? If there is some particle and there is another particle, it will transmit the pressure to the bottom particle through the point of contact, and that is how effective stress works. Effective stress is effective in decreasing the void ratio of the soil mass and mobilizing shear strength. So it basically governs strength by this. The effective stress is having formula sigma dash is equal to sigma minus u, where sigma is total stress and u is neutral stress, or we can also call it pore water pressure. Let us check what is neutral stress, what is pore water pressure. The neutral stress or pore water pressure is the pressure transmitted through the pore fluid. So whenever you listen neutral stress, it is only transferred or transmitted through pore fluid. Means wherever there is some water, there may be neutral stress. But if there is no water, there is no neutral stress is there. This pressure equal to the water load per unit area. So there must be some water. It does not have any measurable influence on the void ratio or any other properties of soil. Therefore, it is called neutral pressure. Neutral stress or pore water pressure is having sign U, and it is having formula like unit weight of water into height of water. Here in the dry soil there will be no neutral stress. That is why we have taken only height H2. So gamma W into H2. Let us find out effective stress. Effective stress is having formula sigma dash is equal to sigma minus U. Now total stress sigma we found out gamma TH1 plus gamma saturated into H2 minus this neutral stress gamma W into H2. So effective stress becomes gamma TH1 plus gamma saturated minus gamma W into H2. So gamma saturated minus gamma W, we know that is submerged unit weight, is also denoted by gamma dash. So effective stress becomes gamma DH1 plus gamma dash into H2. Here gamma W is generally taken as 9.81 kilonewton per meter cube. Let us discuss 4 different cases to determine the effective stress. Let us see first case, partly dry and partly saturated soil mass. So here we can see the line AA. Here it is shown GL, and these sign shows ground line. Wherever this sign is, there is ground line, and inverted triangle is showing water table. So here we can see a soil portion here. Here in upper portion there is dry soil, and in bottom portion there is saturated soil. Now dry soil is up to height capital H1 and saturated soil is height up to capital H2. Water table is below the dry soil or below height H1, we can say that. Now whenever you want to calculate effective stress, you will draw pressure diagrams first, and then you will go to calculations. So let us understand pressure diagrams. So these are 3 diagrams. First diagram is total stress sigma, this is neutral stress U, and this is sigma dash effective stress. If we find out total stress and neutral stress, we can easily find out effective stress. So let us understand total stress. Here above line AA there is no load, so there will be zero pressure. Now coming to line BB, at line BB there is some pressure of the dry soil of up to height H1. Now what is the stress there? That is gamma D, unit weight of the soil, into height of the soil, that is gamma D into H1. Now coming to line CC, here at these CC line level there will be pressure from dry soil as well as saturated soil, as well as neutral stress will be there. Here we are discussing total stress. Let us understand this dry soil is acting some pressure here that will continue to come on line CC. Additionally gamma saturated into H2 will be acting from height H2 and saturated soil for line CC. Let us understand neutral stress now. Neutral stress will only act wherever the water is. In dry soils there will be no neutral stress. You need to remember that. So up to height H1 there is dry soil and there will be no neutral stress. So up to height h2 there will be some neutral stress, and to find neutral stress we will do unit weight of water into height, so gamma w into h2. Now let us move to calculations to find effective stress at level BB. If we stand at level BB, total stress will be gamma d into h1 as shown in the figure, and u will be 0 there. So effective stress sigma dash will become sigma minus u, where sigma is gamma d into h1 and u is 0. So effective stress will be gamma d into h1 only. Now let us go to point CC at level CC. Here total stress will be gamma d into h1, which is coming from dry soil, and gamma saturated into h2, which is coming from saturated soil. Now pore water pressure in previous case at level BB it was 0, but at level CC there will be some pore water pressure, which is gamma W into H2, which we have discussed in the figure. Now finding effective stress, that is formula of effective stress is sigma dash is equal to sigma minus u. Now putting sigma and u value, it becomes gamma dH1 plus H2 into gamma saturated minus gamma W, and it will become finally gamma dH1 plus gamma dash into H2, where gamma dash is submerged unit weight. So here I conclude my lecture here. Thank you.